Next device what we are going to see is triode AC switch. So it is called as Triac. It is a triode AC switch, or in short form it is called as a Triac, and it is also a thyristor. It is having a 3-terminal semiconductor. It is going to have 3 terminals, MT1, MT2 and gate. It is going to have 3 terminals, MT1, MT2 and gate. So it is a PNP device. So you see it is a PNP device. So on either side of the P region, you have MT1 and MT2 in the separate N region. And in one more, in the N region close to MT1, you will be having the gate. Okay, so this is also a 3-terminal semiconductor switching device which can control the alternating current flowing in the load. The role is just like SCR, but only thing the fabrication is going to be different. So this is the circuit symbol of a Triac switch. So you have MT1 and MT2, and you have gate. And the arrow mark is same. Arrow mark is put in both directions to indicate that the current can flow in both directions in the same way, which means the device works in both the directions in the same way. Okay, so that is what the current arrow mark is indicating. And 3 terminals are a MT1 and MT2 and gate is close to MT1. So the gate terminal is chosen close to MT1. So the Triac is, the symbol is shown here. So it is going to be, this Triac can be considered as 2 SCRs connected in parallel but in the reverse direction. So I'm going to connect 2 SCRs in parallel. So see here, this is 2 SCRs in parallel. I'm going to how SCRs we have modeled as 2 transistors connected back to back, right? So I can conclude this Triac to be 2 SCRs in parallel but connected in opposite way. You see this SCR has cathode and anode in this way. This SCR has cathode and anode in the reverse way, but both the gates are going to be same. The control is going to be given by the same gate, but only thing the SCRs are connected back to back, or I can say they are connected in reverse directions. So this will make our circuit very simple. இதே மாதிரி SCR தான் we use this in full wave bridge rectifier, right? So if for one particular half cycle, I'm going to have one SCR is going to conduct. For one particular negative half cycle, one SCR is going to conduct. In that way, during the entire cycle, my entire SCRs are going to conduct. Correct? So in that way, I can say that whatever be the setup, current is going to flow in both directions. The SCR will act as a switch for both directions, and the characteristics are going to be same in both the directions. So see here, for the positive half cycle, you know, for SCR, the current will slowly increase until breakover voltage happens. Once breakover voltage happens, current will increase, but voltage will reduce. And after that, the current will increase abruptly. And this is the case when MT2 is positive. So if I give more voltage to MT2 is positive and MT1 is negative, this is the case, forward bias characteristics. And in the reverse bias characteristics, MT1 is positive and MT2 is negative. So what happens? You will get the same thing. The current will increase till breakover happens. The current will increase till breakover happens. One breakover happens, voltage will reduce, and then current will be increasing abruptly. So when the current is increasing enormously, that is called as on state, and device is said to be turned on. But the region till breakover happens is going to be off state, and in the region in between both on state and off state is called as negative resistance region. So you should not operate the device in negative resistance region because it is going to be unstable. The device is going to be unstable. So either you have to turn on or turn off your device. Okay, and since I am involving SCR, I am going to consider this Triac as a combination of 2 SCRs in parallel. It is understood that if I want to turn off my device, I have to depend only on IH and VH. I should not depend upon the gate voltage. So if you want to turn off the device, either you have to reduce the current below the holding current, or you have to reduce the voltage below the holding voltage. Okay. So this is, so Triac, remember SCR is combination of 2 transistors NPN and PNP, and this Triac is a combination of 2 SCRs connected in parallel but in the opposite direction. They are going to have the same triggering using gate. They are going to have the same triggering using gate. An operation, you see, Triac will also conduct only after reaching the breakover voltage. So till breakover voltage, the device is said to be off. from breakover voltage to the holding voltage, device is said to be having negative resistance. So earlier to that, only leakage current will be flowing, which is very, very small. Therefore, the device is said to be in off state. So when the device is going to conduct, means it is going to conduct after the breakover has happened, and a very large amount of current is going to flow through the device. So you have, since a very huge amount of current is going to flow through the device, if you don't put any external resistance in the circuit, the device will burn or the device will break down, because conventional semiconductor devices cannot withstand huge amount of voltage or current. So the moment you realize that the device is to be in turned on state, enormous amount of current is going to flow, and you can conduct that only by using a resistance in the external circuit. Otherwise, the device may get damaged. During the positive half cycle, MT1 is positive with respect to MT2, whereas the negative half cycle MT2 is positive with respect to MT1. So because of that, you can have conduction is going to happen in both the states. So conduction is going to happen for both positive half cycle, and you can see the graph is symmetric in forward bias as well as reverse bias, right? So it is a symmetrical curve. So which means that this MT1 and MT2 are interchangeable. Even if if I wrongly use MT2 as MT1 or I use MT1 as MT2, my device will still work because the two terminals are symmetric. MT2 positive kudutha, I get the graph like this, whereas if I give MT1 positive, I get the graph here. Suppose if interchange the terminals, when you give MT1 positive, you get this graph. When you give MT2 positive, you get this graph. So the device will not, it's just like the device will not work up because the terminals are interchangeable. MT1 and MT2 can be interchanged for a triode AC switch.